useful, ma'am? Like in which sense? Like CO2 we are detecting, right? So
Yeah,
other
yeah,
than
exactly.
CO2, what can we do?
So we need to know, so our biogas has methane and CO2, right? So we
Yes,
need to know
ma'am.
the process working well and how much methane is it giving, how much CO2 is it giving. So when you use that sensor, you can measure the amount of CO2. So it's
Okay,
simply
ma'am.
for process monitoring. Yeah. And of course, it can be used in other kind of applications as well where CO2 is involved.
And ma'am, can we know about AES company?
So that is what I kind of showed you in my slides. Both AES and AGT are the same. We are sister companies. AES, like I mentioned, Ahuja Engineering is a 30-year-old company. AGT, we started as a startup because we were getting a focus into biogas. So we wanted to see, when you're a startup, you can actually participate in a lot of these funds, you know, DBT, BIRAC, these NSRCL that I mentioned. They're all looking for startups, early stage companies. AES is an old company which was already established in turnkey electrification. So AES doesn't qualify for startup funds and things like that. But since our work is in the initial stages, which means that we are commercial, but we are still sort of looking to grow, we register as a startup. So we had like a sister company, Ahuja Green Technology. So it's essentially the same. We work hand in hand.
Okay, ma'am. It's nice to hear you. And anyone has a question can ask to ma'am.
Ma'am, can you, I mean, there is any way that you can reduce carbon dioxide in your biogas?
See, biogas naturally gives you a certain composition of methane and CO2. Depending on the waste, after anaerobic digestion, you will get the same range if your process is working well. The way to reduce CO2 is to actually purify the biogas. So you'll always get about 40% from food waste, for example, CO2. At that stage, what we need to do is we need to introduce some sort of scrubbing. So we are working on that now. So you can have water scrubbing, you can have amine-based scrubbing. So it will physically react with the CO2 and convert it into a different salt. And then the methane will be captured and you will be able to get a higher percentage of methane by removing the CO2. So that is called upgradation or purification. And yes, practically it's already happening. There are companies who are offering both water-based and amine-based scrubbing. So they are columns essentially, right? Wherein the amine will react with the CO2. So that will be removed as ammonium carbonate. And then the methane will be further captured. So absolutely, that is what you need to do to further convert biogas to bio-CNG and then direct it for vehicles.
Ma'am, we actually maintain the temperature 50 to 60 degrees Celsius. How I are maintaining that, ma'am?
No. That's a very high temperature. It's absolutely not required. We have a mesophilic digester, which means that it's around 35. So what we do is typically, you know, like in Osmania University and all, we don't need to control the temperature because we have pretty tropical climates throughout the year. But in some places, like in Vrindavan, wherein you have 2 to 3 months of cold weather, temperatures can drop to 20 degrees, 25 degrees. What we do is we have, basically we have oil based hot circulation happening. So we've already designed the digester so that we have a pocket and we have, you know, the pipeline going inside. So we circulate hot oil and then we have a control panel to automatically shut it off once it reaches 35. And then we also insulate our digester so that it doesn't lose the heat once it's heated up. So typically we are doing the heating, but we are doing it only in the winter months so that the temperature is maintained around 35 degrees. So it's called the mesophilic anaerobic digestion. You do not need 60 degrees, bacteria will die. You don't need that high energy for anaerobic digestion.
Ma'am, is anything agitation is done in the reactor, ma'am?
So there is mixing, but not a physical agitation. So again, if you have physical agitation, there are some models which people have used CSTR kind of mixing. but they are typically not good for anaerobic digestion because these bacteria again are very sensitive. So they can be shear induced damage. But mixing is actually very important to ensure that you don't have, undigested material, and everything is moving in a uniform way. So what we do is we recirculate the slurry, and we also purge some of the biogas back into the digester. So that essentially, so we take slurry from different parts of the digester and we pump it back in. So it's essentially recirculation. So it's mixing. And then the biogas also, when we purge it, it causes some bubbles and things like that. And then it again comes back with the rest of the biogas. So that's the kind of mixing that we are doing, not direct agitation.
Yes, ma'am. One more question. You have explained about gas and about electricity from the waste, but
Yeah.
somehow that you have mentioned producing hard water for non-cooking and cooking type of methods. Do you have any method or something to say about how we can produce hot water from waste, ma'am? Is it directly or is it from electricity or gas? That's what my question.
Okay.
Is
So you
what my
saw
question.
the chulas in the kitchen, right? The biogas chulas. So essentially, it's very simple. So biogas is methane, right? So we are burning the methane. So what we do is, after we store the biogas, we are piping it and connecting the pipe to a chula. So that chula, when you put a flame to it, once you get the biogas, it's going to burn. So you can use it to heat hot water. You can direct it to boilers, any kind of thermal use. Essentially, you're burning the biogas, and that is being directed for any kind of thermal use, hot water or cooking.
Okay.
Does that make sense?
Yes, ma'am. Yes.
Ma'am, how can we produce the electrical current, like electricity?
So there are biogas generators that are available. If you come to Bonpally, you will see them. Again, we purify the biogas a bit to remove like H2S and moisture. In this case, we are not remove CO2. It's not required. And then that biogas via the pipe is going straight, and there are biogas generators that you can get, gas-based generators. If you have more questions about that, you can interact with our engineers also when you come to the site about how it actually works. And then at the end, what you get is electricity.
Okay, ma'am.
There are losses typically in these kind of generators. That's why we prefer to direct the biogas for thermal applications. But of course, if there's no utility, that's when we go the electricity route. If there's no utility for that particular site, they don't have any thermal application, only then we go for electricity, because there will be some losses of biogas in these generators. It's not 100% of the biogas doesn't get converted to electricity, whereas when you do it for thermal application, you're directly burning it. So it's completely being utilized for the thermal application.
Okay, ma'am. Ma'am, how do you feel for being a woman entrepreneur?
I think it's a very exciting time. There's a lot of good momentum, a lot of support in India. I only know about India. I've never been an entrepreneur in the US. So definitely in India, there is a lot of support. Like I said, there's a lot of programs. As such, I have not faced any discrimination. Still, I think, yes, as a community, there might be people who, look at women and maybe expect a man to come for a meeting, when you go and meet some of these government officials and all. But there has been no direct, nothing direct that I have experienced, honestly, in the last 3 years. People are looking up and treating you equally. In fact, most of the marketing and customer interface in my company is done by myself and my sister. So the one that you saw in the video is actually my younger sister. She is the one who had already started this business, and I joined her. So there's a lot of inspiration around us. And there's a lot of things that you can do. You don't have to hold yourself back. You just have to do things with your sincerity and hard work and drive. I think if you have these 3 things, it doesn't matter what you do, what work you do. Even the kind of work that we do is not tailor-made for women. You know, we have to go to sites, we have to interact with government officials, we travel. I'm talking about as an entrepreneur, when you're running a business, you have to do everything. So we've done all of that. I've done a lot of trips alone, you know, leaving my little kids behind. But you need to know, you know, that why you're doing something. You need to have a passion for it. So if you have the drive and you're willing to give it that kind of effort, it becomes a good, satisfying experience.
Okay,
Ma'am,
ma'am,
I
nice to
joined
hear.
a bit late, ma'am. Which microorganism are you using for
It's not which
producing
microorganism,
biogas?
it's a mixture of
Yeah.
microorganisms that actually exist naturally. So these are anaerobic bacteria. It's a cocktail of microorganisms. And typically these are naturally present in things like cow dung and food waste, right? So we seed the digester with cow dung, which naturally has uh, anaerobic bacteria. And then once we start feeding in the food waste, the waste also has bacteria. So what happens is the digester gets acclimatized to this new culture. Similarly, if you were to feed vegetable market waste, there'll be a different cocktail of bacteria and the digester will get acclimatized to that. Wastewater treatment and all have a lot of anaerobic digestion steps. So there, the wastewater will introduce the bacteria. Typically, to start the reaction, we use cow dung. We also have started using, you know, there are already a lot of digesters around us. So we've also started to go and get some like slaughterhouse slurry and things like that. So they are already rich in anaerobic bacteria. And once you feed in your waste on a regular basis, you only have to do the initial inoculation and then the bacteria will keep repopulating. So it's naturally present. You just have to make sure that you're maintaining the conditions for it to stay good, like make it anaerobic, temperature has to be right, mixing has to happen, everything has to be working in tandem. So the bacteria will keep getting replenished. There are people working on making bacteria in the lab, but so far none of it is commercial. They do things in the lab, but nobody has been able to actually put it in a full-scale digester and show that it actually improves the process. Or that would be great, you know, to have bacteria which can work
Yes, yes. I mean,
salads and for different
yeah.
kinds of food
In
waste.
a
To
commercial scale, it is not there.
it's not there because what happens is that even if you make something in the lab, once you put it in a digester, it will acclimatize to the new bacteria that it sees on a daily basis. So unless you are injecting the culture on a daily basis or some sort of frequency, it is going to acclimatize and change. And so what happens is, even if somebody were to develop it, it might not be economic because you now there's a cost, right? That on a daily basis, you have to add a culture to your digester. So is it really needed? Yes, if it were actually doing something awesome like purifying your CO2 out, uh, then maybe the economics would work out. But again, nobody has shown it till now. I know IOCL is working on a culture which they say they get more than 70% methane. Like we are getting 60% naturally, right? But they have again not shared the data or published the data. So I'm not sure if it really works.
Maybe it is in the patent process. That's why they are not sharing it.
Well, it will be exciting if it's commercialized, but so far it has not been commercialized. So a lot of people are doing work in the lab, but you know, we're still waiting for the verdict to see if these cultures exist and can be economic. That's more important. Can it be economic in your process to use?
Good morning, ma'am. So I have a
Thank you,
small
ma'am.
question like, okay, so it is like if some organization comes and who want to make use of their waste, you're going to set up the plant, right? Rather than that, you only come and set up your plant, biogas plant, for every colony
Mm-hmm.
and take waste from them and
Mm-hmm.
make biogas out of it and sell the output product, right?
Yeah,
Haven't you
absolutely.
thought about like that?
But right, again, how does it work out right now? There's a lot of challenges. The colonies are not segregating waste. The amount of waste that you get, you have to have somebody collect all of that waste, do the segregation. You need to invest money if you want to set up a plant at your cost, because nobody in a colony is going to pay you for a plant. Then you put your money. Then who do you sell the gas to? Who is willing to buy your gas? For how much? So if you start doing all the math right now, that model is not economic. You will not get your returns. So what we are, yeah.
Okay. So you're telling that the normal LPG what we are buying right now is lesser cost than the one which we are going to produce in the plant?
No, what I'm saying is right now, biogas is not a commercial product that I can put in a cylinder and say, this is what I'm selling it to you for. Right now, what we are saying is, if somebody is a waste generator, you set up the plant and you utilize the biogas back into your kitchen, right? So automatically you're saving the LPG. What you are talking about will make sense if it was a very large plant for the economics to work out, because you need a certain amount of gas to be able to bottle it and sell it, right? And also that will involve bottling. So again, there's a lot of logistics involved. How do you pipeline to how many users? It won't be practical for me to pipeline to a community wherein the amount of gas utilized is very less, right? So there's a lot of infrastructure that would be required for it. So definitely these things are discussed all the time, these kind of ideas. But all these things have to be worked out. What are the returns? What are the economics of the project? For large plants, it might become feasible in the future. So if you have like a 30 tons per day plant or 50 tons per day plant, then you will have enough biogas that you can then purify. You can then direct it to vehicles, or you can bottle it and then you can sell it like LPG essentially. But so far, it is still in the initial stages, these kind of business models. So what we are promoting is more decentralized models, that the waste generator sets up the plant for themselves and utilizes the gas. A community model can also work, but then again, there needs to be somebody investing in the plant, giving the land for the plant. So all of those things have to be worked. So we can have a common biogas plant, for example, but then the user has to pay a processing fee for the waste to be collected. And then again, the gas has to be utilized, right? So people have to be willing to buy that gas back. So all those things are logistically huge, and a lot of stakeholders are involved. But definitely there's a lot of these kind of discussions that we have all the time. So it's a very good question.
And what about the ratio, like 100 kg bio waste if we are taking? What will be the output amount? I just wanted to know that.
So for a 100 kg plant, yeah, sure. So 100 kg is actually the smallest plant that we are making right now. So for 100 kg per day plant will produce about 5 equivalent kgs of LPG per day. So that's like 1/3 of a cylinder, so which is pretty substantial if you think about it. But in a household, we don't use that much. I use 1 cylinder in 1.5 months. So, if you start directing this amount of biogas to so many households, there's a lot more money spent in pipelining and bottling and things like that. So right now, our model is working better for larger waste generators, where the consumption of LPG is also a lot. That's where they are able to get the economics, because like I said, some of my customers have say 300 kg per day, like in OU.
Yeah.
We are give them 1 cylinder of LPG a day. That's 14 kgs per day of LPG can be saved. And right now they are using 3 cylinders a day. So then it makes a good sense for them, right? So out of 3 cylinders, they're saving 1 cylinder just by their own waste. So that those models work, but in communities, in individual households, the consumption is very low right now. The waste generation is very low. So segregation and logistics becomes more of a issue. Not the technology is fine, but then the logistics is huge if you talk about a lot of households. What would work is they were doing segregation, they had everything in place where somebody is collecting that waste. Then multiple communities get it to a common biogas plant that the government can fund. So the government should fund such plants. Right now, the government pays, the municipalities are spending a lot of money in waste collection. Then they have contractors that they are giving money to. Then it goes to landfills. So again, there's a processing fee. Instead of that, the government should set up common biogas plants everywhere. And then companies like us can set it up.
Exactly.
And these kind of things can work out. But somebody has to do the investment, right? Identify
Yes.
the land. Because this will have to be set up everywhere in a lot of clusters. So this would be similar to, right now there is a concept called common STPs, right? STP, sewage treatment plant, that people are probably familiar with. Without STP and ETP, no new building can get a permit. So government right now has common STPs and common ETPs. So a lot of your sewage water will go to these common plants, right? So if we had a common biogas plant also, and all the waste would be directed to that, or the government GHMC can collect the waste and take it there, and then use the gas for their own use. I think that would be a really good model to have.
Yes, exactly. It is something you're telling. It is something like people should, the GHMC people who are taking the waste and dumping it over there, they should get there and put it into your
In
biogas
their
one
plant.
by
So
segregating.
they should set up the plant, right? So they need to
Yes,
have
exactly.
the land and the cost, and then as technology providers, we set it up for them. We run it for them.
Yeah, and maybe rather by giving back the LPG to the community people, as you said, it would be better by selling it to some commercial people like porters and all, rather
Absolutely.
than
Yeah.
because they have more consumption, just like you have told regarding the hostel. Because
Absolutely.
we had a talk with ACC Cement where they had
Right.
set up in the same kind of factory for manufacturing cement from plastic waste. That
Right.
is done way back in, they have established way back in 2017, I guess. That's not here, it is in Tamil Nadu. So they
Yeah.
have done the same thing. They have employed people to get the waste and put the plastic waste into the factory. They need to segregate and give it. So
Right.
like that, they got the employment, and it is for free, of course. Nobody wants to sell their waste, right? So they got a lot of profit like that. So here, as a community, I mean, a small idea, just telling. I don't know whether it is feasible or not. The same thing, why can't we apply here is what I thought. Because for every colony or for every area, at least every day we have this market, right? Mandi,
Yeah,
weekly
no,
Mandi.
what you're saying makes perfect sense, but that's where the government has to come in and they have
Ah,
to install these plants because somebody has to own the plant, pay for it, get the land, right? So there's a huge capital cost involved. A company like us, if we start doing the investment also, then it will not be economic because there's a lot of things that have to be in place. So that's what I'm saying. Right now, who owns the waste? We are the waste generators, but it's the municipalities who own the waste. They are the ones who are collecting the waste and dumping it into the landfills. So instead of that, they need to set up these plants, and they can be the beneficiary of the gas. The cylinders. We can purify the gas, and then the cylinders can be distributed to their identified kitchens or I can identify, like you said, commercial customers. But that's where, there needs to be a huge investment.
yes,
Right now, private entrepreneurs are not doing these kind of investments. So government has to really get involved in a lot of these things. So we have a lot of these discussions. We are trying to influence policy makers and things like that so that these kind of models can go forward. We can even just transport the slurry. So what we can do is we can just take the food waste in every community, make a slurry, and then via tankers transport the slurry to a common biogas plant. So then it's even easier, to transport the waste in a closed manner, no smell, nothing. You process the waste at the community, transport the slurry, process it in your plant, and then again sell the gas. So that
thank
is
you,
kind of
ma'am.
what the future should look like.
Yes,
So it's a
thank you for
really
answering my question, first of all. Thank
No,
you
that's a
so much.
really good model that you have put forward. But like I said, there's so many things involved that hopefully in the future things will move in that direction, and that every community will have a common biogas plant.
So
Good morning,
thank you,
ma'am.
ma'am.
Yes.
Do anyone have your query? Suryana, you can go ahead.
Yes, ma'am. So, regarding the reactor design, how is it done, ma'am? Do you use the basic principles of chemical reaction engineering, or are there any computational tools which you employ to design the reactor?
At this point, we don't need computational tools, but definitely we do a lot of calculations because we have a very customized reactor. Depending on the waste, there's a lot of parameters that have to be fixed. Like there's a hydraulic residence time. There is, okay, how much total solids do you have in the waste? How much uh, carbon content, TOC you have. So there are 3-4 things that you have to fix. And based on that, you have to identify how big is your digester going to be. Then we have to do calculations for, okay, how much is the insulation area required if heating is required, which is required in a few winter months. How much is a hot oil required? How should we design the hot oil circulation? Inside the digester, how should we do the mixing so that for a certain volume, everything is well mixed? How much gas to purge, at what flow rate, which pumps to use, at what flow rate. Every little thing needs design and computation and practical experience as well, leak testing. So everything is done in a, not in a simulation way, but actual calculations, actual engineering design. So we do the drawings, we discuss it. Practically, sometimes we face challenges that, oh, okay, we under-designed this or over-designed this. So we have to do it differently this way. Or, oh, we didn't do this correctly, now it's getting clogged. So now we need to make it bigger. Or we need to get a better pump. Or our pumps are failing, so we need to get better technology. So we are constantly doing this. On a daily basis, there are at least 10 such discussions that happen. We are constantly trying to find better ways of doing our process, right from waste handling to feeding to operation, especially in the larger plant, the one that we have just designed, which because it's a very big plant. But in the smaller plants, our process is very stable because we have sold so many. We know exactly how to do it. So we have a template, right? So we know what is the thickness of the digester, what is the size. So we have designed it for like 100 kg per day, 300 kg per day, 500, 750, 1000. So up to in this range, we have fixed the process. We know how to make it. We can make it the same way every time. When we get larger projects, that's kind of what we are constantly now trying to improve. Like we are doing the 10 TPD right now. That becomes a huge chemical engineering or engineering sort of problem. So there, yes, there's a lot of room for improvement, and we are right now constantly updating our design.
And one more question, ma'am. How sensitive is the reaction kinetics to the kind of waste that is being processed?
See, for food, so it is not sensitive. It will still produce biogas, but the production is different based on the waste. So for food waste, you get about 120 meter cube of biogas per ton of the waste. For cow dung, you're going to get like 40-50 meter cube. For vegetable market waste, somewhere in the middle, 70-80 meter cube per ton of the waste. So every waste has a certain biogas potential. Waste handling is very different. Food waste is very easy to digest and crush and pump. Uncooked vegetable market waste, there's a lot of fibers that come. So we have problems where it gets stuck in the pumps and stuff like that. So we have to do a lot of designing. How do we design these things better so we don't have these operational issues? Similarly, like if we get slaughterhouse waste, which we are not currently doing, how do you handle that kind of waste? Because slaughterhouse and poultry waste, they have a lot of ammonia content. So there we have an additional step wherein we'll have to do some sort of pre-treatment, because the ammonia can ultimately have inhibition inside the digester. And of course, there's a smell also that comes when you handle these waste. So we are yet to do those plants, but that's also something that we have worked on in our labs and in our pilot scale, that, okay, if we get these kind of difficult waste, what is the pre-treatment that we will do? So we might have to first remove some of the ammonia and then feed in so we'll have to have a stripping step, So again, there is OPEX and this designing of those kind of things. And then after pre-treatment, it has to be sent to the digester. So that's the difference. So those are definitely, the ammonia waste are definitely something that we have to manage really well, because commercially a lot of the poultry biogas plants have not worked out well because people have not done a good pre-treatment. So it might work for 6 months, a year or two, and after that shut down because of ammonia inhibition.
Thank you, ma'am.
It was really nice to talk to you, ma'am. We felt like happy and resourceful by talking to you. I hope. How did you felt, ma'am?
Ikra.
I'm happy that there's an interest and people want to learn and interact with other people. I do that constantly even now. I try to go to a lot of meetings, conferences, talk to people. It doesn't matter if somebody is less experienced or more experienced than you. There's always things to learn. So definitely keep that spirit, where you're questioning, meeting people, learning. And I think that's really very important to constantly evolve.
Okay, ma'am. And at last, I want to handle it to the Shravan sir. Shravan sir, all over to you.
Thank you, Ikra. Fantastic job. You are hosting for the first time. And, I mean, you're just you're second year, right? Or third year?
Second year, sir.
Second year.
Chemical.
Really good. Fantastic job. One thing I wanted to say, Disha, you handled all the questions. You gave a lot of information to the students. I really, really appreciate it. And Karun, the question which you asked was really good. See, that is where I think you, the students, have to start getting involved as well. You should see whether there is any homeowners associations where there are community meetings, and you should start trying to see how you can collect information, how you can create new ideas within a community, how a community can do things together. So there is a lot of things that can be done, because in US these things are common. The community organizations come together and they'll say, okay, the homeowners association we have here will say, okay, let us do this project. And they'll work on like 1 to 2 years to develop a project, and then they'll invite the private industry to say, okay, this is what we want you to do. And then all the homeowners associations, all the people will say, okay, we'll give you the money for that. So that is something you slowly can get involved. It doesn't happen overnight. All the things that are, if you start slowly involving, maybe in 10 years, maybe in 20 years, you will start seeing a new generation of ideas getting started. Okay. So that is really, really good. And I hope more and more communities will start working together and reducing waste or increasing safety within their communities, and many things they can do. Okay. And so Disha, what we are hoping is I'll call you back later, but what I'm hoping is we could do like we would like to do internship where you can students can come on a Saturday maybe. Okay. Most Saturdays, and then whenever they have a break, like say they have a break for Sankranti, okay, or they have some breaks where they have 3 or 4 days or even 5 days breaks, and during that time they can come. But what I'm hoping is, can we create a program where slowly over time, instead of just waiting for summer or 4th year project, can they start coming from 1st year and slowly building their understanding your processes, learning about what is going on, and then start interacting within the e-cell, saying, hey, this is what we learned from when we went to Disha's digester or Disha's lab, and we are looking at this. And then once they start looking at all this information, they might come up with ideas, and then they can start working some of these ideas within their either through simulation, they can do it right on their computers, or maybe use their own labs within the college. So what happens is, it can be a more of a where you are doing your thing and the students can also do their own way to help you.
We can think about it. Certainly, 1 day a week is probably too little to really get anything out of it. But definitely, like you said, instead of waiting for summer, if somebody is interested, see, it's really up to the student how much they want to learn. Because 1 day a week is something that it's kind of like me opening up my space and somebody just comes and observes, right? Because 1 day a week, how do you design anything or any problem statement that you're working towards or solving or trying to get a output? So what I would like is if somebody had a chunk of time, right? They're coming 4 days a week, 5 days a week for 2 months, then we can have a project or something that, okay, you're going to be looking at this aspect,
Okay.
like a short-term project and then solving it.
That is going to be harder, Disha, because bachelor students don't have that kind of time unless it's summer. Even summer for College of Technology, they don't have it, because their summers, I have seen maybe they get 6 months, 6 weeks.
Yeah.
So that's why we had to work with many companies. We are working with 6 companies now, and all companies, we give them about 15 hours a week. And the students come to the lab, to their company on a Saturday, and the remaining hours they work from their from their homes, discussing, reviewing data, trying to do literature searches, trying to come up with new, thinking about different things. So that's how we have been doing right now, because of the because of the scenario that is in College of Technology.
So I don't envision any offline work, honestly, that I can think of that we can do over the computer. It's all hands-on,
When you
like
do engineering design, you are saying you're trying to do the engineering design.
Not the design, but it's like, okay, we have a problem wherein we want to, maybe a certain plant, we want to see how the process is going. So there might be 1 or 2 assays that you're using to measure that. Going to the plant, getting the samples, also trying to understand how is it working real time. In other case, we had somebody who was working on developing a sensor for temperature, so that it automatically happens. So there, I think there was he was IT based, so he was able to do stuff in the lab, but he was having that skill set and he was directing it himself, but then he was coming to the practically and looking at his sensors, are they working or not, but doing a lot of the coding offline. But that was a sort of a one-off thing wherein he himself had the skill set to develop the coding and all. So we were only helping him in the actual practical aspects of it. But so I don't know, I'll have to think about it with my team as well. Like, what can we do if somebody were to spend 15 hours a week?
And that too, only 8 hours at the company and 7 hours. Right. So only 8 hours. So I wanted to think, I know it is a new idea, but we have been able to get few companies involved in it. So, hopefully, I think you should be able to figure it out. It might take you some time because, like I said, it's something, if you can make that happen, think about the number of students that would be available for you if you can break the project down into many, many parts. So think about it. We can have offline conversations regarding this. And see whether we can make it happen, because what you are trying to do is definitely going to be very valuable for students. If they can work with you, it will definitely benefit them. So we would like to see, definitely the college is very interested in making sure students get as much practical experience as possible.
Sure, let's think about it some more.
Yeah. Thank you, Disha, for coming and talking with all the students. Appreciate it very, very much.
Hope it helped.
It absolutely did. Okay, everyone. Let's.
Thank you. Thanks for having me here.
Thank you, Disha. Bye.
Thank you, ma'am.
Thank you.
Thank
Thank you, ma'am.
you, ma'am.
Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.